Hello everyone, and welcome to AuditNet's Training Without Travel webinar series, IDEA Software Training via Practical Application, presented jointly by AuditNet and Richard Cascarino and Associates. My name is Jim Kaplan. I'm founder and owner of AuditNet, and I'll be moderating today's webinar. Today's presenter and subject matter expert is Richard Cascarino, principal of Richard Cascarino and Associates. Let me have Richard introduce himself and give you a brief overview of his background, and then I'll cover the housekeeping items, disclaimer, and important information about the AuditNet IDEA partnership. Richard?
Thanks, Jim. For those of you who were here on Tuesday, I apologize for you having to listen to this again. For those of you who are not here on Tuesday, welcome. As Jim said, I'm the principal of Richard Cascarino Associates, based out of Steamboat Springs in Colorado and out of Johannesburg in South Africa. I'm broadcasting you today from Johannesburg, as I will be on Tuesday, and then I'll be back in the States. My background: I've got some 30 years experience in IT audit training and consultancy. I'm a past president of the Institute of Internal Auditors in South Africa, and I established the African region of the IIA Inc. I'm also a member of OSACA and the ACFE, as well as the Denver chapter of the IIA. And as you can see on the screen, I've written 3 books so far on auditing and various aspects of auditing. That's me. Let me hand you back to Jim, who will cover the webinar housekeeping.
Everyone should have received the webinar housekeeping and the other slides this morning, so I'm not going to read from them. I will just mention that we are recording today's webinar, and you will receive a link to the recording. Also, because we are operating under NASBA rules, we are required to ask polling questions during the webinar, and CP certificates will be sent to everyone who answers all of the polling questions. You don't have to answer the polling questions correctly, but you do have to answer the polling questions, showing that you're paying attention and that you're attentive during the full time of the webinar. If you're joining us from a tablet or a laptop, you may not be able to respond to the polling questions, in which case you should accumulate your answers and send them to us in a single email. You can send questions via the chat box on your screen. I'll be moderating the chats and the questions, and I'll pass them along to Richard, and he'll answer them either during or at the conclusion of the webinar. After the webinar is complete, you will have an opportunity to provide feedback via a survey, so please pay attention to that when you receive it. The next slide provides you some information about the disclaimer. Again, I'm not going to read that slide, but please pay attention to that. And at this point, I just wanted to mention about the AuditNet IDEA partnership. AuditNet has entered into an agreement to provide access to subscriber content to IDEA Premium supported users. If you're currently a Premium supported IDEA user, you can access the AuditNet content at no cost. For more information, go to the AuditNet site for details on how to log in and access more than 2,300 templates. There is a video with a process that walks you through how you log in to get access to the site. So let me now turn the floor back to Richard so that he can share with you how to get the most from IDEA software. Richard?
Thanks, Jim. Okay, as I said, this is the continuation of Tuesday's presentation on statistical sampling. For those of you who were not here on Tuesday, you've missed the theoretical part, but nevertheless we'll pick up from where we left off, and if there are any questions you can always ask them during the course as we go. What we're going to cover today is using IDEA to do sampling, different types of sampling, systematic sampling, random sampling, stratified random sampling. And we're going to look at monetary unit sampling as well as classical sampling. By classical, I'm referring to the attribute sampling and variable sampling. We'll take a look at correlation analysis and trend analysis and time series analysis. And then we'll take a look at how all of this lot leads in to continuous monitoring. And that leads us into the writing of scripts and the editing of scripts, which is what we'll be picking up on next week's webinar. Okay, So, without further ado, let's kick off the way we normally do by starting IDEA, bringing it up, setting the working folders, and setting up the definitions. Since I've been sneaky and already brought it up, whoops, I'll just jump straight into it. Okay, so we're going to start off by looking at the different types of sampling. If I move into my analysis bar, click on analysis, you can see over on the right hand side we've got a variety of different types of sampling. Attribute sampling, monetary unit sampling, variable sampling, random selection, and others. And we'll take a look at each of these in turn, see how they work, when you would use them, what you're using them for. But the first thing you've got to do before you can actually use any kind of sampling is you've got to get your hands on the raw data. So we'll go back and pick up the raw data file. I'm going to bring it in from my home button and from Desktop Plus. Okay, and that takes me in, as usual, into my import assistant. This should not be news to any of you. We're going to pick up the customer database, which we know is an MS Access database. And as usual, that's going to be sitting in a directory called tutorial. Down at the bottom is my customer database. Now, the customer database is an MS Access database. MS Access is one of those databases which is ODBC compliant. Okay, if you go back to the earlier days of computers, we had the advent of different types of database. We started off with the hierarchical databases, and that was the IMSs of this world and the totals of this world. And basically it was in the structure of a hierarchy. So the employee would own the employee record, and the employee record would then consist of certain fields, and so on and so forth. And that was a very powerful way of looking at data. It was also very easy because typically it mapped on to organizations. Organizations were structured in hierarchies. So it was easy to look at the data in the same kind of format. The problem with that was if you wanted to look at data across the database, you couldn't. You had to go down the hierarchy, up the hierarchy, across, down the hierarchy, up the hierarchy, across, down, up, across. Typical use for that kind of database was heavy-duty, high-volume number crunching, because it was very, very fast to access your data as long as you didn't want to do anything too fancy. And that lasted until people started saying, well, you know, I'd like to go a bit beyond that. And we saw the advent of the codicil or network types of databases, where now you could go up, down, or across using built-in chains, pointers, and linkages. But the problem with that was you had to have those built. If you needed to use a linkage that wasn't there, you had to take the whole of the data, unload the database, redefine it, and load all of the data back. Now, in a large database, that could take hours, it could even run into days. It also meant that you had to keep the chains and pointers up to date, even if you weren't using them all that often. If you added a new record, everything had to be updated. So we came to the concept of the relational model database, which said we will take the data and we will put it into tables. And we will define a relationship for the table when we need to use it. So for example, I could say I've got a table of employees. Contained in that employee table is employee name, employee number, salary, and the department code. But I don't want to store 20 characters of department name in every employee's record. I'll just have the department code. And I'll have a separate small table with the code and the name for each department. And then when I want to use it, I can say take the employee number and the employee name from the employee file and take the employee department name from the department table where the department code in the employee file equals the department code on the department file. And it would build that relationship as you needed it. Use it once and then throw it away. Okay, and that's the ODBC databases. Now Microsoft Access is itself an ODBC compliant database. The problem with all of the previous ones was that every manufacturer did their own thing. So you had IDMS, and you had on a Unisys, you had DMS2. Sperry had System 2000. Now those were all codicil network databases, but they were all slightly different. The idea with ODBC was you define the structures once, and you put that into a driver that you can bring in. And with that driver, I can then go into that database without having to redefine it and relearn a different language for every single one. So we'll bring it in from our customer MDB, and you'll see on there there's a variety of tables. In this case there's only one, and it's called database 1. So I'm going to take the whole lot and I'm going to output it to a file called customer. I've already got one called customer, so I'll say yes, replace it. And there's my customer database. Okay, so now I've got the raw data, and you can see in there I've got the customer number, the first name, the last name, the country, the status of that customer, and the credit limit for that customer. So I would like to do some sampling from that customer file. So I'm going to go into my analysis, and now you can see all of the buttons under sample are available. So I'm going to do some sampling, and what I want to do is some sampling, systematic sampling, or I can do other kinds of sampling. Now I don't know why they did this, but over in Explore you'll see there's also a button called Statistics, and that's where you would do correlation, trend analysis, and time series. So occasionally people say to me, I've done the sampling, now I want to do correlation. Where do I find correlation? It's over under Statistics. Okay. So I'm going to go into my attribute sampling, and it says, tell me something about your population. Well, I want to have a look at a few of them. I don't want to look at too many of them. I can do it with attribute sampling, or I can go in through random sampling, or I can go in through other. Now you see we've got statistics over here with those correlations. We've got other on the right hand side with systematic sampling, stratified sampling, and the generation of random numbers. Okay, we looked on Tuesday at random number. Let's take a look at systematic sampling. And if you remember what I said on Tuesday, the ideal would be pure random selection. But sometimes it's not possible because it's not in the right order or it's not structured appropriately, and then I might have to go for a systematic selection. I've got 341 records that I can pick from. I want my sampling interval to be every 10th. So I want to change my sampling fields, I want to change my computation, and I can go and change my sampling interval. My sampling interval I want to pick up every 10th out of the 341. I'm going to start with 1 out of 341, compute. So it says it's going to pick up 35. Okay, and that's fine so far. I'm going to start with record number 7. I've picked that at large. I picked a random number between 1 and 10. And it's now going to pick up 10, it's going to pick up 7 and 17 and 27 and 37 and 47 and 57. And if I say OK now, it's going to come out on a file called systematic sampling. And there are my 35. No, it's picked up 34. Now I said I wanted 35. The 35th one would have taken me over 341. So it's given me 34 out of it. Now I can take that sample and I can go away and do whatever testing I want, etc. Okay. That's one way of doing it. That's doing it using systematic sampling. I'll go back into my customer database, and this time I'm going to simply go to random sampling. Number of records, I still want to look at 35. I'm going to start with my starting number of 7. My random number seed is a field generated automatically by the computer. You'll see I've got 10891. And it will tell you do not change unless necessary. If I deliberately want to start with a particular seed key, I can do that. But there's a potential to bias the sample. So normally it's okay just to leave it. You have a choice. Do you want to duplicate records or not duplicate records? Shall we allow a particular record to be selected twice? No, I don't want to do that. I'll leave it. Fields. I can pick the fields I want to come out in my sample, and I'll leave it picking them all. But you can select just the fields that you're interested in for the purpose of this particular audit. And if I say OK now, there's my 35. Oh look, this time we've got 35. Okay. Because we were looking at the whole file and we were not saying take every 7th. And if you look at the numbers, you'll see that the customer numbers are different on that random sample. Okay. Let me go back into my customer database, and this time we're going to do a stratified random sample. So we're into Other again, and we'll come down to Stratified Random. Now, do I want to do it numerically or character stratification? I'm going to take it as numeric. And it says statistics are not available for all fields. Do I wish to create statistics for all fields without statistics? Yes, I'll take them. Now, what do I want to stratify on? Well, I'm going to take my credit limit, and I want to total on, and I'm going to click on my credit limit again. Now it's saying, what strata do I want? Well, I can leave it at 2000 and just click and drag it and pick up however many I want. So I've now divided it into 11 different strata. I can also change the fields. I can also remove that one and take them all out, or simply highlight one and take that one out, okay, if I wish. I can build in whatever criteria I want. So one of the things I might want to do is have a look at selecting based on something other than that for my increment. I might want to do it every 5,000. If I wanted to do it every 5,000, I can start it from 2,000 if I wish. I'll remove all of those fields in the meantime. I'm going to start from 2,000. I'm going to start with strata of 5,000. If I click an upper limit, it's going to give me 2 to 7. Pull it down, 7 to 12, 12 to 17. Now I can say, okay, from there, from 17, I want it every 10,000. And I'll pick it up there. So I can split the strata. And I'm going to create that. I'll say OK. And there's my strata. And you can see there I've got the number of records. I've got the sample size. So in that strata, we have exactly none. Or have we? There's my random sample in that strata. How many records fit there? 52 of them fit there. 31 of them fit there. Okay, there were 0 in there. There are 161 that fell between 2,000 and 7,000. So I've done my stratification. There's my sample, and it's telling me where the distribution of that sample is. Okay. Where the sample size is where the number of records is greater than 161, I can now tell it how many I want out of there. You'll see that we're in a file called stratification, but we still have at the bottom 341 records, so they're all still there. And if I come down to the bottom, you'll see total is 341 records. So now I've got a choice. I can say in my sample size on the first one, there's 161 records. Give me a sample size of 21. I want 21 drawn from there. Then I'll take a 5 out of the next one. I'll take a 2 out of the next one. I'll take a 1. I'll take 1 out of there. So I can bias the sample wherever I want. And you can see that we've now got 36. That's too many. Give me 2 out of there, I said, not 5. So I've got 21 plus 5 plus 2 plus 1 plus 1. And if I look down the bottom, I've got 30. So I'll say give me another one, and another one, and another one. I'll make that 3. My choice. I'm influencing the sample. And when I've got it, I can say OK. And there's my sample that I've picked. Now I haven't biased the sample to the extent of saying I want particularly these records, but I have biased it by turning around and saying I want to select this number out of that section of my stratification. Okay, there were my stratification records, and there's the random sample that I've picked out of that. If I look at my stratification, you'll see over here we've got them sample record number ascending as an index because that's what we said we wanted, and there's my selection. Okay, so we've done attribute, we've done random, we've done systematic, we've done stratified random. Let's take a look at dollar unit sampling. Okay, so I'll go back to my customer database and I'm going to do monetary unit sampling. I'm going to start off by saying I want to plan. Okay, what do I want to sample on? Well, again, I'm going to look at my credit limits, my confidence level. I'm an auditor. I want to work at 95% confidence level, which is, as we know, 1.96 standard deviations on the variability. What is my tolerable error? My tolerable error is going to be 5%. Oops, not 65%, 5%. My expected error rate is going to be 1% because we're pretty good, so we don't expect a major problem. Okay, estimate. It says the sample size corresponding to those objectives would be too large, or you would have too many errors for compatibility. Why? Because it's saying there's my value of the sample population, and if I work on that, I'm going to end up with far too high. So let me drop my maximum tolerable error down to 4. And again, it's telling, try decreasing the expected error, the tolerable error, or decreasing the confidence level. If I take that back down to a 90%, and I do my estimate now, still telling me too high. Let me take my tolerable error down to 3%. Still too high. So what are we saying? We're saying that in this particular case, dollar unit sampling would not be appropriate. Classical variable sampling would be more appropriate if the population expected to have a high error rate. Okay. Oops, I put my tolerable error in at 30% rather than 3%. But it's still too high. So in this case, it's not going to give us what we want coming out of that. If I drop that down to my expected error rate was 0.5 or 0.05. Still too high. If I drop that 3 down to 0.05, oops, not 3.05, 0.05, and I drop that down to 0.01. The tolerable error must be greater than or equal to 1 and less than the total value. So it keeps you right as you're going. It won't let you make a mistake and draw erroneous conclusions. So I need to have a tolerable error of at least 1, and my expected error rate, I can run that down to 0.5% and do an estimate. I've got an expected error rate greater than half of the tolerable error. It's inefficient. Do I wish to continue? Okay, so it will try and keep you right. It will not it will let you do it. I mean, if I say yes, it will tell me that the sample size calculated is greater than 1 million or greater than the value of the population. So with a small population like this, I'm going to have to work at a very much lower confidence level or a very much lower tolerable error or expected error rate before this thing would actually work. Okay. Happy. So, as I say, it tries to keep you right. Let's take a look at classical sampling. Classical sampling, and again, I can go back, make sure I'm in my customer database, and I can go in on my preparation. And this is what on Tuesday I was referring to as variable sampling. Okay. Once again, I'm going to take my credit limit. I'm going to take off that automatic sampling of high value items. I don't particularly want that. I can specify a number of strata, and then I can go into advanced. Within advanced, I can tell it my minimum sample size that I want. I know that I want my 35 records. My minimum target number of errors in the sample, I'll leave it as 0. And as you scan across it with your cursor, you can see that it will tell you, give you some clues. If you're expecting any errors, you might want to specify it to optimize the estimation technique. We'll leave it at 95%. We'll leave the minimum sample size, and we'll say OK. Now I told it I wanted 2 strata. I could have changed that, but there's my estimation of book value errors. Let me cancel that one and go back in with my monetary unit planning. I'll leave it there. I'll put my confidence level back up to 95%. My tolerable error will be still sitting at 0. My confidence level I want it to 95 instead of 90. And I can do I beg your pardon, my mistake. I'm in monetary unit. I'm intended to be in variables. Go into my advanced settings, leave that at the 35, leave it at the 90. Everything's okay as we wanted it to be. But I'm going to change that strata. I'm going to give it 10 strata. 10 equals strata. The high value amount must be greater than 0 if I'm doing automatic sampling. I don't want automatic sampling. Go. It cannot determine the automatic strata boundary because the high value cutoff is too high. Okay. So you've got to be careful when you're messing around with this lot that it is going to give you what you're looking for. Okay. Otherwise, you'll get what is known technically as unpredictable results. Now, remember we talked on Tuesday about the errors within stat sampling. One of the problems that you've got with stat sampling is when it tells you, you run it, it comes up with an answer which is wrong but plausible. And you can give a false recommendation based on what you're looking at. IDEA tries to stop that happening. And I said I want 10 strata. I can specify the boundaries, and we're back into this again. So I can specify all of the boundaries I want in there. Okay, manually. If I want to go for that level. I'll go back to the 2 I had and leave it at that. Okay. From here, if I go into the next, there's my plan. So at a confidence level of 0% desired precision because we haven't done anything to it, there's where my strata are going to come out. I can use that and I can say, as part of that, I want to change that confidence level and put 95 in there. My desired precision, I can put a figure in there for my desired precision, and I'll put my desired precision in at 10, expected error rate to be 1, oops, not 9500, 95. Compute me the sample size, and it's going to give me 20 out of stratum 1 and 15 out of stratum 2. Okay. One or more strata must be sampled at 100% in order to meet it. So now I'm in a position to say next. I'm going to do an extract from that. I'm going to use my random seed, and it's picked 1387. Again, I'm going to leave it. That will be my sample name, finish. And there it's pulled it all out. And it's showing me which record number in that sample, what the audited amount is. Remember, when you're doing this kind of sampling, it's cumulative monetary amounts that it's working on. Okay, so it's telling you what you should be looking for. I've got a question, does the value need to change to percent? We can do that if we look in a, well, cancel, go back into my customer database. And if we looked at within the values, we're looking at the percentage. I beg your pardon. Let me cancel that. You're looking at monetary unit sampling when you're doing your planning. Does it have to be percent? Can we change it? What was the question? Can we change it back to percent? The answer is yes. Okay. Which brings us to our first question, polling question. So we'll select a poll and launch it. Polling question number 1, and remember, you don't have to get it right, but you do have to answer. Okay. Polling question number 1, random sampling allows the auditor to select a beta risk, select a tolerable error, select the starting number, select an expected order. Please vote now. Almost complete. A couple of more votes to come in. Remember, you don't have to get it right, but you do have to vote. All it proves is I haven't actually put you to sleep yet. Note the yet. And we'll close it and share the results. We have 83% who say select the starting number. And if you remember when we were doing a random selection, that was exactly what we said, random sampling. What starting number do I want to select? Okay. So I will hide it. And you can see when we went into a random sampling, in the middle was starting record number to select. So the lowest record from the range that we want selected, and then everything from there on. Okay, let's take a look at that attribute sampling again. Attribute sampling, we're looking at our population size. Now remember, attribute is yes or no, it's the dichotomous scale, it's either right or it's wrong. So we know that our population size is 341. We have an expected deviation rate. This is well controlled. We don't expect it to be more than 1%. Our maximum tolerable error rate is going to be 5%. If there's more than 5 errors on file, heads will roll. And the confidence level, I want it to be 95%. Now, with that 95%, I can now go and compute. And once again, what it's telling me is that I can do my sample, pick my sample. If I find one error, okay, my probable percentage deviations, I can be 95.14% sure, which is what we're looking for, at least 90%, that the error rate is 5% or less. Now you'll see there's a percentage deviation 1.25. That's the percentage deviation in the population. Okay, not necessarily in the individual. Sorry, I beg your pardon. That's the percentage deviation in the sample, not in the whole population. Okay, what this is telling me is a 95.14% chance that everything's okay. If I find two deviations, then I can have a look and see that I can only be 83% sure that the error rate is 5% or less. Now at that, I cannot say the error rate is greater than 5%. All I can say as an auditor is at a 95% confidence level, the error rate is not 5% or less. Okay? As long as that 95 stays above 95, I can say at a 95% confidence level it is 5% or less. And that's all I can say, the only conclusion I can make. Why? Because that's what I started looking for. Now if you see what happens when we shift the expected error deviation rate, let me shift that to 3% and go compute. Now my sample size is 188, and I am able to sample all 188 of those and find up to 6 errors and still be 95% sure that the overall error rate in the population is 5% or less. Okay, there comes a point, if I shift that to 4% and recompute, you'll find that I can get 11 errors wrong, but my sample size, I need to look at 272 out of 341. So the closer the expected error rate is to the maximum tolerable deviation rate, the closer it gets, and the bigger the sample size needs to be sure to get that level of confidence. Okay, because you can see there that 95.06 we're okay, 86.72 we are not okay. So the closer you get, the worse the sample size becomes from an audit perspective. Okay, let's take a look at some of those other statistics that we can work on. So let's have a look at correlation analysis. Now the files that we've got aren't really going to be much help in correlation analysis, so I'll close those down. And what I want to do with correlation is I want to take multiple variables and I want to put them together. So I'm going to use my import assistant, back to home, back to my desktop plus, and this time I'm going to pick up some Excel spreadsheets. Okay, and the first Excel spreadsheet I'm going to pick up, again from my tutorial, is one that's called country emissions. Okay, so the first one on there is country emissions. I'll say next, and this is going to give me my carbon totals. The first row is the field names, and I'm going to say OK. So from 1985 through to 2004, these are all of the carbon emissions country by country, which is all very interesting. But what I really want to know is how does that compare to the rest of the world? What is the correlation between that and the rest of the world for this particular country? So I'll go and bring in another one. And the other one I'm going to bring in is also an Excel spreadsheet. It's going to come from the same directory, but this time I'm going to bring in the world's total emissions. Okay. Again, the first row is the field names, and OK. So there's those years from 1985 to 2004. And I want to find out how each of the countries correlate against the world's total emissions. Now, how do we do that? Well, the first thing we're going to have to do is link those two together. So I'm going to start off by going to my country emission file, and I want to join the databases. And there are various ways that we can join databases. You can see up at the top my customer access toolbar. I'm going to add join in there. So there's join two databases. I can also do it by looking through file and then look at picking my databases, opening the databases and joining the databases. Okay, so there's my join databases. I'm going to match two databases based on a common field. Okay. If I don't want to use a button bar, I can look at viewing the data, and I can say that I want to tie these things together and join them together. So I'm joining my basic country emissions. Okay. Now, how am I going to do that? Well, I want to take all of the fields, country, year, and carbon, from my primary file. What do I want to tie it to? Well, my secondary database, I'm going to look at, and I'm going to go down looking for world total emissions, the last one. So I'm joining those two databases. Okay, based on what? Well, I'm going to have to tell it how to match those two. On my primary, I have the country. And then for my match data files, I don't want to match it on the country, I want to match it on the year, and on my secondary file I'll match it on the year. Okay. Now I've got some choices. I've got the file name is going to be join database. Well, in this case I'm not. I'm going to put in emissions. Do I want matches only? Outputting only those records where there are matches in both databases? Or matches including all of the records in the primary file, which are all of my countries? Or only records with no secondary match? Or only records, or all records in both files? Or records with no primary match? Now we should find them all. Okay. I need to tell it how many fields I want from the secondary one. I want the year and the total. So I'm happy with that. Go join me the database. Okay, and you'll see that it's now created a joined database. There's the country, there's the year, that's the carbon, that's the year from my world total, and that's the total from my world total. So I now have a joined database. I now want to correlate the two. Okay. So I can go into my analysis and go into my statistics and go into my correlation. What do I want to correlate? Well, the fields I want to correlate, I'll take, what would you suggest that we take? Your choice. I want to correlate the carbon from the first file, the country file, and correlate it against the total. Okay. That's fine so far. But based on what? I'm going to select my audit unit, and my audit unit will be select an audit unit field. I'm going to base it on country. And I want to include all of the audit units. Now, there's a problem. It's not allowing me to do this. And it's a fault that I've found in IDEA, that initially it won't let you do it, but you can get it to create it. So initially I'm going to say include all of the audit units. I can't do it. I'll say OK. Then it tells me the audit unit has not been selected. Now I've got the country, I've picked the country, but it won't let me do it. It will not let me say make sure they're all there. Okay. So there's a fault in the system that prevents you from doing that. If I shifted that to year 1, there are all the years. If I shift it back to country now, there are all the countries. Okay. Now I see that as a bug in the system. If you're not quite sure what happened there, let me cancel it and go back. I'm going in and I'm going to do correlation. These are all the fields in my joined file, and I want to take the carbon from one country and compare it to the total. I will select an audit unit file, not an audit unit field, and the unit I want to compare to is country. But it won't let me select all of them. And it doesn't matter what you do, it won't let you select them. If you change it to another one and then go back to the one you want, now you can select them. And in this case, I'll say include all of the audit units. Okay. I'm going to create the results. I'll create the output. And there's my correlation. Okay. So the total compared to Belgium, Belgium has got a tiny amount. As you move up, you'll see China has got the largest amount. Now, as usual, giving people lists of numbers really doesn't buy you an awful lot. If you can put it into a graph, it's so much better. So you'll see underneath where it says emissions, we now have some choices. I can alternate between graph and grid. I can export it to a selected format, Adobe, whatever I want. I can print it and so forth. I'm going to go into my graphs. And there's my graphs showing the correlation right across the board. Okay. Once again, I can look at that correlation and see exactly what it is. It's 0.5. That's where you're getting a matching correlation. Within the graph, I can change certain things. I can personalize it. I can copy it to a clipboard. I can go into the gallery. If I go into the gallery, I can pick a different type of graph. So I can say, I don't want that. I'm going to do it using that. And when I highlight one of these, I can see the correlation 0.620 out of 33.625, and so forth. Okay. I can change it into 2D or 3D. I can change the palette. I can change it into a nice bar chart. And I can change the meanings of all of these values. I can output it as a bitmap. I can output it as a meta file. I can output it as text only. I can go back to the text. Now, what does all of that mean? Well, if we look at that in terms of graph, and I go back to that basic line graph on the gallery, what it's showing is that the world's total emissions showed a steadily increase over that period. Okay? But the data does show some small year-on-year decreases. Over here, it kind of decreased and it slightly increased there, etc. The country to world correlation ranges from minus 0.8, which is a high level of negative correlation, all the way up to the top. Okay. Now what does that mean? If I go back and look at the raw data, there's up at the top we have Belgium. So what it's telling me is that some countries have got trends that are decreasing over a time. So Belgium's contribution to world climate, if you like, to world carbon emissions, is decreasing rapidly. Luxembourg, so on and so forth. If you get down near the middle, you'll find that somewhere around about here is Norway and Ireland, okay, which indicates that their trend over the years has been neither up nor down. Okay, but if you go and have a look down at the bottom end, and we start looking at things like New Zealand, it's got a 0.8, which says there is a very high level of positive correlation. Okay, so they're highly positively correlated to the average, which means that while other countries are going down, they are going up. The United States is sitting at 0.759. If I go and have a look at the country emissions, and I go down to United States, and you can see there the carbon range is going up, and it's going up steadily. Okay, but it's not whether it's going up or not, it's whether it's going up in proportion to the way the world's transmissions are going. Because we can see the world's transmissions are also going up. Question is, are these better or worse in proportion to the rest of the world? And if we go down to the bottom and have a look at, for example, Belgium, which was the lowest one, you'll see Belgium has been steadily decreasing while the rest of the world's been going up. Okay, so that's what we can do with correlation. We can look at how information in detail correlates to totals and try and extract some meanings from that. Okay, and that brings us to our second polling question. And our second polling question says, with correlation analysis, data in multiple files can be correlated, data within a single file can be correlated, non-matching data can be correlated, graphical results are not possible. Please vote now. And again, we've just got a few people still to vote. I'll close it and share the results. And the correct answer is that multiple data in multiple files can be correlated. Now, to do it, you have to bring them together, tie them together into one file. So there's an argument that says B could be accurate in some cases, but generally we're talking about A. You can take multiple data from multiple files and correlate them. Okay. Now, let me hide that and come back. And let's take a look at what happens now if we want to look at those country emissions and do a trend analysis. So let me go back to my country emissions and take a look at the data for 2005 and 2006. I'm going to take it for Australia, and you can, oh dear, we don't have any data for 2005-2006. What I can do is I can use this to do a forecast. Okay? How do I do a forecast? Well, first thing I need to do is take all of the data. I wanted to create a forecast for 2007 based on the 2004 based on the history, and then compare it to the actual. Now there's my 2004, so I've already got that. I want to see how I can do it. So the first thing I want to do is create an artificial forecast for 2004, and then I'll compare what I've got with the actual. So I'm going to do a direct extract, and I'm going to extract it to a file which I'm going to call pre-2004. It's going to hit all records, but I want to extract it only if the year the country year is not greater than 2004. So I beg your pardon, it's not equal to 2004. If I check that, it tells me I've got a valid equation. So I can now say OK. Okay, and I've now got pre-2004 as my file, and you can see it goes up to 2003. So now I want to do a trend analysis and see if I can forecast 2004 and see if it matches what was actual in reality. So I'm going to go in on my analysis, and I'm going to do a trend analysis out of my statistics. Now, what am I analyzing? I want to do a trend analysis on carbon. Okay, so my trend is on carbon. My audit units, again, is going to be country. Now it's giving me all the countries. So I'll say include all of the units. In this one it worked, and I could see all of the countries. I'm going to say generate forecasts. Okay, I only want one forecast at the moment. I want to forecast 2004. And you'll see there are 3 databases marked down at the bottom. There's a trend analysis database. There's what they refer to as a create forecast database, and the MAPE database. Now the MAPE stands for the mean, absolute percentage error. So that looks at the actual values and the straight line forecasts to try and see, does this look okay? So I'm going to create all three databases. Okay. The results is going to be my trend. So I've got a choice. What am I going to do? I want to create an extracted file. And I'm going to say from data extractions, okay. Okay, so what it's done now is it's created those three databases, and it's showing me the actual data. It's showing me the actual data is going up and down. It's showing me my forecasts, and it's showing me the degree of trend fit. Okay. Fine so far. I'm still sitting with my country emissions. I'll go back into my pre-2004. Now I want to have a look at the results of that pre-2004, and I want to create an extracted file for the actual 2004. So I'll go back to my country emissions, and there's my actual 2004. And again, I'm going to create a direct extract. So you should know how to do this, because it's the same as we did before, but this time it's for equal to. So I'll let you go ahead and do that. All we want is only 2004. And I'll give you a couple of minutes. Okay, let me go and do it. I want to do a direct extract. The file name that's going to come out is year 2004. And again, I want to select criteria, but this time it's going to be that the year is equal to 2004. And there's my actual 2004 as opposed to my forecast 2004. That's my pre-2004, and I've also got my forecast 2004, my trend analysis, etc. So now to see how accurate that forecast is, I'm going to join my extractions. And you can see over on the left-hand side, I've got my trend analysis forecast, my trend analysis, etc. And I want to join my 2004 emissions. So there's my actual 2004, and I'm going to join it to my forecast, my carbon forecast. How do we join files? Well, once again up here, I'm going to join those two. My primary database is year 2004. There are 60 countries, and I want to include the field with my carbon forecast. Yes? Okay. So I'm going to take my actual carbon. I'll take all of these, in fact. My secondary database is going to be sitting down under country emissions, pre-2004, and I've got the forecast, the MAPE, and the trend analysis. I'm going to pick up the trend analysis forecast. Okay, so that's my secondary file. I need to tell it what to match on. I want to match on the country from the first and the country for the second. And the fields I want to bring in is just the carbon forecast. And if I tell it OK now, I can say OK again, and it's put my carbon and my carbon forecast. Now you can see they're not quite the same. Question is, how bad is it? Well, what I'm going to do is I'm going to take that file and I'm going to join it. And again, I want to take all of the fields, so I'm happy there. I'm going to select my second database, and my second database this time is going to be my emissions pre-2004 trend analysis MAPE. Okay, my mean absolute percentage error. I'm going to use my country as a match field again. Country in the first, country in the second. But this time I want all of the records in the primary file. Not just matches, I want all of the records in the primary file. The field I want is my carbon slope and my carbon MAPE. I don't need the country because I've already got that. And I'll say OK. And from here we can see where we've got our carbon MAPE, we can see our carbon forecast, we can see our carbon slope, and that will tell us how accurate this is being. Okay, so we can interpret this and have a look at how accurate we believe this to be. Okay, for our forecast. And then we could do the same for a 2005 forecast. We don't have anything to match it against, but it will allow us to then say, how much can we depend on this forecast? So what else can we do? Well, we can do a time series analysis. These are all some of the advanced statistical things that we can do. If I'm doing a time series analysis, I don't want it from these databases, so I'll close those down. Close down all of my joined databases, my emissions, etc. My carbon emissions. And this time I want to look at a time series analysis looking at unemployed statistics. So I'm going to go into my desktop. I'm going to pick up, again I'm using an Excel spreadsheet. So it's coming in from my tutorial. And you'll find on there one called unemployed. So I shall bring that in. First row is the field names. Okay. Again, I can go into my advanced analytical. I can see month by month, well, not month, but 4-week period by 4-week period, from 1989 onwards, what the unemployment rate was in the different states. Okay. I can now go in again on my analysis and go into my statistics and have a look at time series analysis. This time I'm wanting to have a look at the people. Okay. I'm going to select an audit unit field, and the audit unit is going to be for all states. Once again, it's now given me all of the states, and that's as it should be. But if it doesn't come up, if that hadn't come up, try going in and picking something else and coming back to the one you're interested in. As I say, to me, I've reported it as a bug in IDEA, and they should fix it soon. Okay. So, my model information, I've got some choices. I want my seasonal length. I'm doing a time series analysis. Seasonal length, I've got 13 seasons, I know, 13 4-week periods. My forecasts, I want to generate forecasts for all 13. A calendar month, well, a calendar month is 4 weeks. Okay, so I'm going to generate forecasts, and I'm going to take a calendar month as being 4 weeks. I'm going to call it time series. I'm going to create all 3 databases. Timescale calendar, 4 weeks. Okay. Create all 3 and say OK. And again, it's created this for the people, and it's showing actual data, fitted data, and forecast data. So if I look at the unemployed database, you can see in there all of that information. I can jump it back into the raw data, and I can look at the individual periods. I'm looking at the MAPE. Okay. I'm within my unemployed. I can also have a look at the actual unemployed. So there's my unemployed. I can have a look at unemployed 1, unemployed 2, and I'm seeing all of that raw data. Wherein lies the problem? It's showing me the MAPE is 10.85. Problem is, I don't see the actual MAPE. Why? Because I didn't create it. So I can go back into my unemployed. There's my unemployed by rate. I will go back in my statistics and go into my time series. I want it by people. I want it for all, for the state, all states. I'm going to choose a calendar of every 4 weeks, and there are 13 of them. I want to generate forecasts for all 13, and I want to create those 3 databases: time series database, the forecast database, and the MAPE database. And the series name is going to be time series. I'm back to it again, and down here I should find time series. And if we look at each of those, there's my time series 1, my forecast, and my MAPE. If I have a look at the time series, there it's giving me my forecast period from 1 to 13, and it's looking at the people, and it's looking at the people reference, people fit, and the MAPE. If I look at the forecast, there's my forecast for each of those periods. If I look at the MAPE, it's showing me the people MAPE. Remember, when we're dealing with the MAPE, what you're looking at is you're looking at the mean absolute percentage error. So how much of an error is it going to be? If I go into that unemployed database, the raw unemployed database, and I look over to the right hand side, you'll see we've got the results, time series. I'm in the time series, and I can have a look at the graph, and I can examine Colorado. Okay. I can look at the actual data, etc. Okay. So lots of different ways you can do time series analysis, and you can say I'm accurate, I'm inaccurate, etc. And that takes us to our third polling question. Polling question number 3. is looking at mate files. And the question is, a mate file includes the multiple analyzed percentage error, the mean absolute percentage evaluation, the mean absolute percentage error, the multiple analyzed percentage evaluation. Number one, were you listening? And number two, can you find it in your notes quickly? We have 69% voted. And for those of you who want to be pedantic, you'll find it on page number 1. When we looked at correlation analysis, and into trend analysis, and our mean average percentage error. I've already told you, sorry about that. So the correct answer was, I'll close the poll and share the results. And lo and behold, it was the mean average percentage error, C. Okay. Okay, so that's taken you through what can be done with a whole pile of different analytical techniques. Now, when would you use which one? Well, that depends. It depends on what you want to know. It's entirely up to yourself. Now, one of the things that can happen, particularly when you're doing things like time series analysis, etc., is you may want to actually do this on a continuous basis so that you can see trends as they are happening. And that's become a very hot subject. So we'll take a look at continuous monitoring. And we'll take a look at the difference between continuous monitoring and continuous auditing. Why now? Why has it become a big deal now? Well, basically because we've got huge banks of data and increasing business dynamics, which means that you cannot wait for things to happen, and you cannot come in at the end of the year and look to see what happened. You need to be able to look as they are happening on the fly. And then we've had all of the problems that we've had over the past few years, everything from 9/11 through malfeasance crises. We've seen complex and creative business models coming in, and we've seen a range of regulations coming in. HIPAA, SOX, Patriot Act, Basel, Dodd-Frank, you name it, it's come in. And it means that business can no longer sit back and look at things in retrospect. They need competitive development of controls to match the development of the business. Now, there's a distinct difference between continuous auditing and continuous monitoring. How much auditing you do will depend on what management's role is in continuous monitoring. And it's an inverse relationship. The greater the role of management, the less of a direct role audit needs to have. If management are doing comprehensive monitoring of internal control, internal audit can reduce their effort and simply monitor management's monitoring. If management are doing very little ongoing monitoring of controls, then it's going to require a lot more effort and a lot more resources and a lot more use of IT from an audit perspective. So when we talk continuous assurance, it's a mixture of management's internal controls and audit's assessment of how that function is operating. In essence, continuous auditing is part of internal audit. It's owned by internal audit, it's performed by internal audit, and it's primarily detective. Okay? We're continuously auditing, looking for things which may be going wrong, and perhaps allowing us to fix them before it becomes out of hand. And it's up to internal audit. They are responsible for evaluating and monitoring and continuous monitoring activities of management. Continuous monitoring is owned and performed by management. Be careful. When you start off doing continuous auditing, it's very easy for management to say, can you do that every day for me, or every month for me, or every week for me? And all of a sudden you are not auditing the control, you are the control. The answer is no, I can't do it every day for you. But I can point you in the direction of the tools, and you can do it for yourself, and I will come and make sure that you are doing it. Owned by management, it can be either preventative, detective, and or corrective, because continuous monitoring itself is an internal control. As audit, we do not exercise internal control, we audit internal control. The nice advantage from a monitoring perspective is that it gives immediate notification to management of any problems that seem to be occurring, which allows them to fix it before it gets out of hand. As a result, things like fraud can be reduced and your risk management can be improved. And that kind of continuous monitoring you can roll out across multiple IT systems. And it doesn't have to be the operative management who are doing the continuous monitoring. It can be a second level of management of supervision, monitoring what's going on. As far as its use in fraud prevention and compliance, key drivers are the fact that the laws and regulations for fraud prevention are changing all the time, and they're becoming more constrictive and restrictive all the time. Fraud itself has got a direct impact on the profit and loss. So preventing losses from fraud is critical, not from an audit perspective, from a management perspective. It also has an indirect profit and loss impact. If word gets out that you have been defrauded, you can be hit on your business reputation, you can lose clients, and it will certainly affect your ability to attract new clients. So how do we implement, how does management implement continuous monitoring? Well, to detect anything, fraudulent, unauthorized activities, money laundering activities, your systems need to be monitored on an ongoing basis. Now we know that all application systems have the capability of producing activity logs or transaction logs, but to differing formats. So what we need is a centralized monitoring dashboard that allows management to look across business transactions and across IT systems, and there are several around. Okay. However, although all systems are capable of performing these logs and saving these logs, not all systems do. In some cases you'll find that the logs have been switched off because management are using other control techniques other than the logs, and therefore you don't have the capability of doing continuous monitoring using those logs. It needs to be fed a different way. as far as the audit trail is concerned, it's an imperative. You have to have something that management can follow. I hate the term audit trail. I know we use it in auditing and it's common, but if you try to convince people that an audit trail is needed, they'll look at you and say, but I'm not an auditor. That's for the auditors to worry about. I don't need to worry about it. So I prefer to refer to it as a management trail, where management knows this result came from that input resulted in that output. And that means that as far as continuous monitoring or continuous auditing is concerned, to look at fraud prevention and compliance, you need to get right down to the nitty-gritty. Details of the finest granularity are needed, particularly in near real time, as close to real time as you can get. Now that's a complete waste of time and effort to have that kind of logging going on unless somebody is looking down at it. So there has to be a drill down analysis down to that level of granularity so that you can actually look at the raw data and say, now what is that actually telling me? We need to ensure data source quality and data level assurance. And we can use that as a proof for our internal controls that they are functioning as intended. You can also use that if it comes to a court case. It means that you need to get right down to the nitty-gritty and do transaction-level intervention. As far as continuous auditing is concerned, for an auditor to implement continuous auditing, what is needed? Number one, an ability to implement and understand IT at an in-depth level. You need to understand what is going on inside that box. At the operating system level, at the application level, at the data file level. And then you as an auditor need to accumulate sufficient evidence that you can communicate to the powers that be, to management, etc., where they are in respect of their internal control objectives, their risk control objectives, if you like. So what are we looking for? Continuous auditing is a type of auditing that produces audit results either as the events happen or in a short period of time thereafter. When I say a short period of time, I'm talking milliseconds. So rather than talking in terms of continuous auditing, which is the industry generic name, it would probably be more accurate to talk in terms of instant auditing. Bearing in mind, instant does not necessarily mean frequent. This could be a transaction type that only happens once every week, but I want it to be monitored and I want to know now when it happens, not at the end of the week. So instant. If you don't have continuous monitoring, if you don't have the capability, then management themselves have to maintain an activity audit trail and enforce access control standards. Who can get in? What can they do? Ban standardized administrative passwords. Nobody must be able to get to those audit trails and delete them, change them, edit them. Change management within your IT systems needs to be strictly enforced so that nobody can get to the programs and change them. And need to facilitate independent inspection of the records of the overall infrastructure management. That's an awful lot of work to do. It would be a lot easier if you could just set it up and get the computer to do it for you. And from an audit perspective, your knowledge has to stay current. And I don't mean current as to what's happening in IT or in IT audit. I mean what's happening inside your organization. New systems coming in, changes to existing systems. The auditor needs to be up to speed on what's going on all the time. And that brings us to our next polling question. Our next polling question is looking at True continuous assurance is dependent on internal audit's efforts in monitoring internal controls, primarily detective in nature, primarily preventative in nature, or dependent on management's effective monitoring of internal controls. True continuous assurance. Who is there all the time supposedly checking on everything? I'll give you another couple of seconds, then we'll close the poll. We'll close it and share the results. And the results are showing that the majority of people went for dependent on management's effective monitoring of internal control. And that is what continuous assurance is all about, because they're the ones who are there minute by minute, second by second, with the appropriate tools to do that continuous monitoring for them. Continuous auditing is not going to give you continuous assurance. At the end of the day, it's all about meeting the business need. What business need? Well, we've got all kinds of regulatory compliance issues and control requirements. We've got the pressure on internal audit to deliver value while maintaining their independence. There's a problem because not every auditor is a skilled IT auditor, and not every auditor needs to be a skilled IT auditor. It's a question of looking at the business and saying, what is it that needs to be done? What is it as an auditor that I need to know? Is there an appropriate technological security? And if so, how do I put it in place? All we're saying is that there's a need for timely, ongoing assurance over the whole risk management and control systems. And continuous monitoring simply provides a more frequent, more timely analysis to better manage any control deficiencies and increases in risk. As far as looking at the difference between the audit role and the management role, that role of continuous auditing depends on management's role in continuous monitoring. Okay, it's not up to audit to say, I am going to audit all of these things. It's up to audit to say, what is management doing? What is left that they're not doing? And then we will fill in the gap, and it should not be a big gap. As far as continuous monitoring and auditing is concerned, we were trying to establish how to efficiently and cost-effectively sustain that control assessment and the testing effort. We're trying to establish how to know on a timely basis when control deficiencies occur and how to quantify the impact of those. Now, all of those are not audit functions, those are management functions. We can assist, but it's not our job to do it for management. How to improve effectiveness of control, how to gain that overall assurance of the effectiveness of those controls on an ongoing basis. Why do we need it? Because what we've been doing up to now has not necessarily been that good. The retrospective view, where we come in at the end of the period, at the end of the day, tomorrow morning, at the end of the week, at the end of the 6-month period, and look backwards, occurs far too long after the transaction has taken place, and it's too long and too late to do anything about it. Because you're not doing it instantly, you're losing timely visibility into control risks and deficiencies. So if something happened 3 months ago, you can be pretty certain that's carried on happening for the last 3 months because of that loss of timely visibility. Your alternative is to test all transactions for compliance with the controls at or as soon after the point at which they occur. Now, the overall control objectives of processing of transactions haven't changed. We're still looking for accuracy of transactions, completeness, validity, authorization. We're still looking to ensure that our control mechanisms are efficient and effective. We're still trying to enforce things like segregation of duty in order to achieve regulatory compliance. So the control objectives haven't changed, whether you're dealing with high volume systems or low volume systems. The thing that's different is how we can implement the appropriate monitoring of those. So we can use our continuous auditing, as opposed to monitoring, for doing continuous control assessment. Is it as bad as it used to be yesterday? Is it worse? Is it better? We can identify control deficiencies before they get out of hand. We can identify fraud, waste and abuse while there is still time to do something about it. There was a case in South Africa. We had a young lady worked for a bank, Snowy Mshweshwe, and she took them for 9.6 million over a 2.5, 3 year period. Now what she was doing should have been picked up within a couple of weeks. She was doing interbranch transfers and she was kiting them. They were growing and growing and growing and growing and growing. All her supervisor was checking was that nothing was more than a week overdue. But if they'd been monitoring the volume of transactions and the average value of transactions on an ongoing basis, within a week they would have picked up that hers were growing at a rate which was disproportionate to all of the other clerks that were doing that kind of work. And continuous control assessment would have picked that up literally within a week or two. While fraud was low value and easy to control and contain. It also facilitates continuous risk assessment, where we can look at the consistency of the processes, how well are they working. That facilitates the auditors to develop an enterprise-wide audit plan. And we can reduce the stress of individual audits by automating what we can and only follow up on what we need to. So what do we need to do continuous auditing? Well, first of all, for each business area, we need to be able to identify the control objectives. What are you trying to achieve? Then establish tests that will tell us it's being achieved or it's not being achieved on an ongoing basis as it happens. We need to identify tests that will identify suspect transactions. And as I say, looking at the Snowy Mshweshwe case, transaction profiling would have said this is running out of profile. It's growing too fast, it's growing too slow, it's growing sideways. It's not as it should be. We can subject all transactions to a test bed of interrogations on an ongoing, regular, timely basis. We can create scripts in IDEA and set them to run automatically on an ongoing basis, in the background or every 5 minutes or every 2 minutes or anything we choose. We can identify all of the transactions that fail those metrics. Then as auditors, it's not up to us to fix it, it's up to us to notify the appropriate personnel. First of all, you've got a problem with your control systems, you should have picked this up. And secondly, we can then investigate discrepancies and recommend the correction of the transactions and at the same time correcting the control problem that allowed that to happen. So what do we need to be able to do all of that? Well, we need first and foremost the ability to access and normalize data from different areas right across the organization, tying files together, operating and offering a comprehensive range of tests to effectively address control objectives. The first time through, we'll do it using IDEA, and we'll do analysis, and we'll do this, and we'll do that, and we'll do the next thing. I then want to take all of that I've done, select the bits which are most relevant, put them into one batch file and say, okay, run that every day. Handle large transaction volumes with no negative impact on operational system performance. Not always easy, but it can be done. Provide variable parameters for tests so that it's not the same test all the time, every time, because people learn how to avoid it. So we have to run this continuously, but with the option of management to say, okay, let me look at a 5% error, let me look at a 2% error. Today I want to look at a 1% error. We're getting better, I want to reduce it. We're getting worse, I want to increase it. And maintain the security and integrity of both the tests and the results. Challenges for doing that. Number one, you've got to get hold of the right data and you've got to get access into it. If you're going to do continuous auditing, you're auditing against some kind of measurement standard. What is the appropriate measurement metric? Then set the appropriate thresholds for exception reporting within your interrogation software and develop the appropriate metrics to prioritize exceptions. It could be on value, it could be on frequency, it could be on a variety of things, while minimizing that impact on the system's overall performance. And that brings us to question number 5. Question number 5 says continuous auditing can be used for examination of the consistency of processes, retrospective examination of evidence, providing less frequent assessments to better management controls or manage controls, or determine the impact of control deficiencies. What are you going to use continuous auditing for? Give it another couple of minutes, a couple of seconds I should say. Remember, for NASBA CPE you have to vote. As I say, you don't have to get it right. And we won't tell anyone who voted for what. Okay, we're going to have 100% vote in. Let me close it and share the results. And the bulk of people have gone for examination of the consistency of processes. And that really is what it's all about. Whether the controls are working or not, are they consistently working, are they consistently not working? So if that's what we're trying to achieve, how do we implement it? Well, you have to establish what it is you're trying to achieve as an auditor and set up your requirements. You're going to have to gain executive level support because you are going to be going in looking at areas which traditionally have been seen as management's monitoring role. And management may well take this as you are insulting them because you're saying they're not doing their job right. No, we think you are doing the job right, but we want to assess how right you're doing it. Select the appropriate technology solution, identify the sources, understand the business processes and risks, build the audit skill set. And I don't mean learn how to use IDEA. I mean learn the business. Learn what needs to be monitored and how. And then manage and report the results. Timing. It takes a lot of front-end effort to work out what you need to look at, what you're trying to prove, where the evidence will lie, how am I going to get to it, how am I going to be able to interrogate it, and then setting the thing up. And you can be sure as guns are guns that as soon as you set it up, someone's going to change the system. So you're going to have to change your continuous auditing. If you're going to use alarm-based intervention where you leave the system to run until it goes beep and says there's a problem, Then you have to define the appropriate metrics, automate the interim work, and go for continuous confirmation. And the whole thing is a complete waste of time if you then follow it up with detailed testing of everything in sight. You use detailed testing only when exceptions are noted. If we look at how continuous monitoring has evolved over the years, we started off with manual processing with full user intervention required, and the auditors coming in at the end of the year and looking back and doing sampling. From there we moved to individual macros with some user intervention required, and that's where we go in as auditors and periodically test selected areas, and most organizations are sitting somewhere between those. For many organizations, they get to the individual macro level and they're stuck there. We can get to menu-based applications with limited user intervention required, and that's essentially where the auditor can set up a couple of scripts, hand them over to the users and say, run that every month. Or you get up to the full automated testing and continuous monitoring with no user intervention required, with frequent testing for leading indicators of problems only. Now that sounds great in theory. There are things that will stop you doing it. Obtaining the data easily on a systematic basis. Standardizing that analysis process by identifying the key risk areas and the leading indicators. And that's tricky. And that involves a lot of liaison with management. What are they looking at? What are we looking at? How we should be putting this together. Establishing a champion within audit to spearhead the creation of those custom analysis routines and allocating time to complete the work, because when you're first developing this, it takes time, it takes effort, and it takes a hell of a lot of elbow grease to put it together. Avoiding the use of multiple applications to produce the desired result. We want this to flow smoothly, to be continuous. And wherever possible, moving away from that historic looking back and moving to proactive monitoring instead of periodic retrospective testing. And that brings us to our final polling question. Final polling question says, continuous auditing requires that control objectives are predefined, thresholds exist for deviation rates, exception reporting is already in place, or that disparate data from across the enterprise is accessible. Please vote now. Okay, we're almost fully voted. It's a slightly trick question because you do have to have the control objectives defined, but they don't have to be predefined. Okay, we can go ahead. I'll go ahead and share the results. And as you see, it's disparate data from across the enterprise is accessible, is the primary requisite. You've got to be able to get your hands on the data, otherwise you can't do anything. How do you do it? Well, one of the ways you can do it in IDEA is you can implement repetitive scripts. How do you implement repetitive scripts? Well, there's an example of a script. You saw when we looked at IDEA and we picked up, for example, that time series analysis. If I pick up that time series 1, I can look at the history and it shows me what I did I took the unemployed, I imported from Excel, and that's how I did it. And there's my IDEA script for doing it. Now I can take that script, I can copy it, I can make it an executable script in its own right and say run that every month or every week or anything I choose to. And that's where we're going with the next webinar. We're looking at scripts and we'll be looking at how to make these repetitive. Are there any questions?
Thank you, Richard. I don't see any questions that have come in. So let me at this point, if you advance to the next slide, here is the supplemental information. There is the link to Introduction to AuditNet for IDEA users, as well as other value-added resources that we have, including links to the vendors with software demos. I wanted to thank everybody for joining us today for today's webinar, and look forward to you joining us next week, where Richard will get into the next slide, which gives the schedule of what is coming up. Basic script writing in IDEA, followed by using advanced functions, and then the advanced script writing classes 1 and 2. So again, thank you all for joining us today, and thank you, Richard. Do you have any last thoughts that you want to share with our attendees?
The trick with doing all of this is practice. Okay, you've got the software, you've got the files, you've got the slides. Go and practice it. If you get stuck, remember that over all of it, we have this wonderful concept called help. There's a little question mark up at the top right-hand side that you can click, and you can say, I'm trying to do correlation. How do I do that? And there's it all there, and it will take you through exactly how to do it.
That's perfect. And what you said before just rings so true. It's like that old joke, how do you get to Carnegie Hall? Practice, practice, practice. If you don't use this,
That's it.
You're going to lose it. So you basically need to start taking what Richard has shared with you and applying it to every audit and every project that you're working on. So again, thank you, Richard, and thank you all for joining us. And we look forward to seeing you again next week. CPE certificates will be sent out tomorrow. Thank you. Bye-bye.
Bye.